All right, welcome to today's Explainer. We're stepping into a hidden, highly technical world that, frankly, every single one of us relies on, yet almost nobody actually thinks about. We're talking about the mind behind the machine, modern elevator controllers. You know, you press a button, the doors slide open, you step in, and you're whisked away. Simple, right? Well, the sheer volume of real-time calculations happening behind the scenes to make that ride smooth and safe is absolutely staggering. So get ready, because we're about to decode the incredibly fascinating anatomy of the elevator brain.
Okay, let's dive into this. Have you ever noticed how the most complex engineering out there often hides behind the simplest interfaces? That is exactly the radical philosophy of elevator controls, the manufacturer whose systems we're unpacking today. Instead of locking their tech behind a massive wall of confusing jargon, they engineer their microprocessors under a super strict mandate: simple, solid, supportable. The ultimate goal here? Zero defects in every single process. They firmly believe that advanced tech shouldn't just be powerful. It absolutely must be accessible, maintainable, and reliable for the mechanics actually working on the ground.
So here's our roadmap. 1. The elevator brain. 2. Simple, solid, and supportable. 3. AC versus DC traction. 4. The perfect ride. And 5. Diagnostics and unrestricted support. Let's get to it.
Section 1. The elevator brain.
Let's start right at the central command center. In modern systems, a sophisticated microprocessor controller acts as the literal brain of the entire elevator operation. Two of the absolute heavy hitters in this space are the V800 traction platform and the H800 hydraulic platform. Whether we're talking about a mid-rise hydraulic system or a high-speed gearless traction system just zipping up a massive skyscraper, these universal boards are the nerve center. They manage absolutely everything, from critical life safety functions like fire service, all the way to that complex group dispatching logic that magically decides which car comes to your floor during the morning rush hour.
Just think about what this brain handles every single second. It ensures strict compliance with ANSI fire safety codes. It actively calculates selective door timing, so it literally knows exactly how long to hold the doors open for a car call versus someone calling from the hallway. If someone's blocking the doors, it initiates a nudging operation, using reduced torque to safely push them closed without hurting anyone. It's constantly chatting with other cars using smart duplex communication, and it even has built-in timers to automatically bypass stuck buttons or just take a malfunctioning car out of service entirely. It is constantly thinking, evaluating, and reacting.
Section 2. Simple, solid, and supportable.
So, the crucial point is, all those heavy specs are super impressive, but what good is a supercomputer if you can't actually maintain it? That brings us right back to their user-friendly philosophy: universal backward compatibility. Look, in an industry where aging equipment is a massive, incredibly expensive headache, this specific architecture is a total game changer. It means building owners can take replacement PC boards with current, modern components and plug them directly into older units. You can update a vintage elevator to current tech without having to rip out the entire system. No forced obsolescence.
And you know, the industry has clearly responded to this philosophy. 10,000. That's the number of these specific elevator controls units currently in service worldwide. It's not just a number, it represents the massive scale of trust that building managers, engineers, and mechanics have placed in this supportable equipment.
Section 3. AC versus DC traction.
Let's shift gears away from the digital brain for a sec and look at the physical hardware actually moving the cab. The V800 product line is amazingly versatile, and it cleanly organizes all these complex engineering choices. Basically, your building's height and speed dictate your drive type. If you have a low to mid-rise building, keeping it under 150 feet per minute, an open-loop AC system or a standard hydraulic system does the trick perfectly. But the moment you're managing a mid to high-rise, needing speeds up to, say, 1,500 feet per minute, you are instantly moving into closed-loop flux vector territory.
And this brilliantly illustrates why you choose one over the other. An open-loop system gives you 2% to 6% speed regulation. Honestly, that's perfectly fine for a slower everyday lift, but a high-profile, high-speed building, that demands absolute precision. The closed-loop system uses advanced digital encoders to constantly feed live speed data back to the brain, guaranteeing a precise speed regulation of better than plus or minus 1%. That is exactly how you guarantee that totally seamless, imperceptible stop in a luxury high-rise.
Moving on to Section 4, the perfect ride, PVF.
Okay, we know how the brain thinks, we know how the motor pulls, but what is the secret sauce that makes a high-speed elevator ride feel like you're literally floating on air? It's a technology called PVF, position velocity feedback. Let's decode that alphabet soup. Systems without PVF often just use a basic timer to guess when to slow down. But PVF? It's a dual-loop feedback system. It mathematically computes an idealized, actually, scratch that, an optimized velocity profile, based on the car's exact position and its current speed. This guarantees a buttery smooth, stepless acceleration and deceleration, entirely eliminating that stomach drop feeling, regardless of how heavy the car is or which direction it's going.
This V800-PVF add-on is widely considered the ultimate ride comfort option. It is highly, highly recommended for buildings with multiple, varying floor heights. Think about it. In some buildings, the elevator might not even have enough physical distance to reach its top contract speed in a single short jump between floors. PVF calculates the perfect custom speed profile for that exact, unique trip in just milliseconds.
But how does a dry piece of technology actually know the physical layout of the building? Well, it literally learns it. Step 1, a technician simply runs the car the entire length of the hoistway. During this single uninterrupted run, Quadrature pulses generate precise digital feedback of the incremental car position. Then, the system brilliantly and automatically records the exact correct speeds and slowdown points for every single floor straight into its non-volatile memory. It maps out the reality of the building completely on its own.
And the results of that learning process? 3/16. To put that into perspective, this massive, multi-ton piece of heavy machinery rushing up a shaft can automatically position the elevator car to within 3/16 of an inch of the landing cell. That is mind-blowing. Absolute pinpoint precision. Section 5, Diagnostics and Unrestricted Support. Let's move to and see how this builds a bridge from high-tech ride quality right back to human-centric building maintenance.
Because honestly, the best technology in the world is totally useless if you aren't allowed to fix it. The massive real-world benefit here is their non-proprietary maintenance guarantee. All diagnostics are on board. You don't need to hook up an external laptop to read fault codes. There's no secret, heavily guarded service tool required. Spare parts, training, available to absolutely anyone without restriction. This means building owners are never locked into those frustrating, expensive proprietary maintenance contracts. They own the equipment, and they own the right to have whoever they want service it.
Now, what's really interesting about this slide is the radical commitment they make to the people actually in the field. They offer unrestricted availability for multilingual telephone technical support. Imagine a mechanic is sweating in a hot machine room at 2 a.m. trying to troubleshoot a glitch. They aren't just left in the dark. They have a direct line to knowledgeable, factory-trained technicians to help them out, totally free of charge. And they back up the whole shebang with the number 24, a full 24-month warranty period from the date of shipment. It's a true testament to their absolute confidence in providing what they call bulletproof field technology. They build it solid and they stand right behind it for 2 full years. Which leads us with a final, pretty provocative question. Who really controls your building's elevators? Is it the building owner, or is it a proprietary maintenance contract that effectively locks them out of their own machine room? By demanding non-proprietary, supportable infrastructure, complete with a brain built for precision and transparency, the power is put back exactly where it belongs. Thanks for joining me on this explainer. And the next time you step into an elevator and experience a perfectly smooth stop, you'll know exactly the kind of microprocessor brain that made it happen.